So Mike, you can continue looking
Okay.
at the DBOSS and HDSTP objective.
So our primary objective, as I mentioned, is to provide the trainees or the individuals who are going to use this information with the most relevant and up-to-date information based on the hazards, the equipment, and the procedures. And as an example, being able to understand the brace position for a 4-point harness that's been recommended by the Canadian Transportation Safety Board and adopted by a number of offshore operators. What's the difference between that and some of the other brace positions that are being used internationally? So understanding that the hazards that are associated with that, the type of equipment, so the stroke or the crash attenuating seats, we call them stroking seats, understanding what procedures go along with those, and then using that information to be able to develop an effective emergency response plan. So that's the primary goal of the DBOSS and the HDSTP, is to present relevant and up-to-date information for the individuals. So in addition to that, what we want to be able to do, and Mornay, if you can just bring up the next point that's there, is to be able to utilize the extensive gap analysis that Mornay, Steve, and I have worked on over the last year. And these two projects represent approximately a year's worth of work for us. And we've started off by looking at all the international standards that were available at the time. That's Canadian, North Sea, Australian, any other standard that we could look at, and to be able to leverage that, to be able to cover off all the components in the DBOSS and the HDSTP to meet and exceed all the current international standards. The material contained in the program ultimately can be used to certify the individuals for the current offshore safety and survival material. And we understand there's definitely a gap between the training and the real world. We know that every organization is going to be limited by the pieces of equipment that they have. The geographical location they're working in is going to have different pieces of equipment for safety and survival. We know that there's going to be different standards that occur across the planet. But what isn't different is the theoretical material. In almost every case that we look at, if we can utilize the latest information from research and standards and best practices and put that into one standardized platform, then we know that the individuals are going to receive the best information that they can use to create that survival plan. The gap between that real world and training environment, we're actually trying to close that as much as we can. And we know from research that people learn just as well in an online platform as they do face-to-face, as long as the information is relevant for them and they can utilize that and put it into the practical application. If it's irrelevant, if it's generic, it's difficult for people to span that gap from one point to another. So if we can leverage the most up-to-date and relevant information, then the gap gets smaller and smaller. And that's ideally the goal, is that people can utilize and put into action the information that they're presented with. So,
yeah, I think that's a very good point, Mike. I think also Patrick Bosman, I know, is on the call as well from PHI, and also representing LA Offshore, LEDEX, chairman and HSAC. One of our biggest challenges at the moment between the program itself and my own company to develop the passenger safety briefing videos is the massive disconnect with different operators want to have different things added in the safety briefing video. Now, I know there's a significant push with the HSAC, which is the LEDEC advisory conference, to look at what are the minimum requirements to be added in a passenger safety briefing. So that's a significant thing that came out of the Sombra accident as well, that people were not really fully aware of how to operate some of the emergency equipment. So that's going to be one of the challenges that we want to run with industry, to look at the videos that we develop for customers, end users, and things like that, and what the role of aviation advisors or company personnel, duty holders have in the development of the video. So we really need to work as an industry collaboratively to come up with a very defined, there shouldn't be too much discrepancies what we want to have in a safety briefing. Some companies want to have a safety briefing video of 5 minutes. Some companies want to do a full UAT program and run for 14 minutes. So where's the healthy balance? So that adds another thing that we want to discuss as part of this program that needs to be very well integrated and implemented in the industry. So when we look at some of the key features of DBOSS, what are they? We wanted to have a complete solution. When myself and Mike initially touched base, we've pretty much known each other for the last 10 years. When I was flying with Cougar, Mike did a lot of work offshore Newfoundland. Obviously, the Cougar accident was a significant part of that time in 2009 when the accident happened, and stayed in contact. But when we started developing this program, we wanted to look at what is lacking in the industry. And when we looked at this complete solution, to look at the whole DBOSS, which is obviously introduction to the offshore industry, similar to BOSS, in the HDSTP stuff, with the UIT stuff, we wanted to have a program that we can roll out for instructors, advanced instructors for that matter as well, instructors that will benefit from the training program as well, and also the participant. So we wanted to sort of run the solution out. It's not just a standalone plug and play for your trainees. It will also enhance the quality of your instructors, that they can benefit from research that has been done in the past. It was always very difficult to come by. Some of these reports ends up in regulatory boards or authorities, but never ends up in the hands of the training facility. So now we've taken all of that stuff and we've made it ready available within the program. Anything else for that matter, Mike?
There's a couple of questions that are coming in that I'm just going to address as we move forward, but I don't think there's anything to add at that specific point right now.
Okay, great. The next thing that we moved on, we're obviously in contact with one of the Met providers that we're looking at a solution where we want to make sure that when people are in the simulators in the pool, we provide animations that will support that training center. So for example, someone flies S92s offshore in Newfoundland. There's one training center in Newfoundland that operates only the S92. We want to be able to plug and play, take the S92 animations that we've created that shows everything: flotation deployment, raft deployment, the jettison of the windows, the emergency creating of the emergency latches. We want to be able to update the program. So every training provider will have the opportunity that we will be able to customize, plug and play specific aircraft that operate in that region. So that's going to be another significant thing. And I think Mike has seen this in the training, and I think you guys might admit that as well. When someone has completed the training at the UIT facility, I mean, the METS is very well set up. The METS is almost to the centimeter within the same proximity and size of a real cabin, but it doesn't give the look and feel of what that cabin would look like. So they might do a Dunker training program 2 months, and only later they fly offshore. But that'll be the first time that they actually get to see the helicopter from the inside. So with our animations, that will give the passenger another added value to really familiarize themselves. When they do the training, before they can do the pool exercise, they can get to experience what it feels like sitting in a 92 and looking at a real window being jettisoned or something like that being created.
I'm just going to add to that slightly. It's the that disconnect that I talked about, or that gap that's there. The visual aids that are used in the classroom, or in this case for us, the DBOSS and HDSTP, actually closes that gap. We've seen in previous research that those visual aids allow individuals, to be able to develop a mental model in their head. And in fact, there's not a lot of difference in the components of the brain that are used when developing that action plan to what's done in practical application, as long as the visual stimuli is as close as possible to the real thing. So if they visualize in their mind moving their hand to a reference point, pushing the window clear, grabbing the outside edge, undoing their harness and pulling themselves out, if they can envision the actual aircraft, the skill set, the skill acquisition retention is actually different than if they look at a generic bit of information. So we know that that helicopter specific information is extremely important. I'll just pass that back over to Mornay.
You can actually continue, Mike. I think this is down your alley as well, just looking at the advanced instructor training, competency training, not only competency, but maybe recurrent training programs. You can just maybe continue on with that last bullet point.
Okay, so one of the things that we find too is that when the instructors don't necessarily have the opportunity, because they're busy doing what they were hired to do, and that's train individuals, the development of a course training standard often is missing some of the latest information. It's maybe integrating a couple of the new accidents, but at a superficial level. And that's because there's not necessarily somebody at a training organization who's devoted specifically to improving that course training standard, updating the presentations, updating the information for the instructors, things like helicopter accident statistics or the offshore events that have occurred, marine accidents. There's a lot of information that comes out, and it's difficult for individuals, the instructors in particular, to keep up on all of that. So that gets passed down to the trainees. One of the ideas behind the DBOSS and HDSTP is that we can actually develop different levels for different individuals. We can have an advanced instructor training program that covers not just the required material by the training standards, but also information related to situation awareness, decision making. There's a number of components looking at a specific event and talking about it. So the anatomy of a ditching, a particular ditching, or an offshore investigation that's going on for the installation or a vessel. And then we can also look at just a basic instructor program and a trainee program. So the ability to pull out different components depending on who needs the information, because obviously we don't want a trainee having to go through 3 weeks of material. They just need the information that's important to them, but we have the ability in a digital platform to be able to add and remove components as events occur and as new information is presented. So as new research comes online, we learn more about how people gather skill and are able to retain that. That information can be put into the program as well. So Mornay, I don't know if you have anything else to add there.
Yeah, I think that's a great point. What we intend to do is to keep the content the same and just, like Mike said, adjust the content. So we're looking at the whole holistic solution. So the material the instructor will look at, and the reduced version for the participant, they'll be the same material. So there'll be a nice connect between the advanced package that we obviously prepare the instructor for their duties and their roles and responsibilities to train the personnel well. But the information that will be then presented via the digital learning will be very relevant and identically the same, just in a reduced format. So that's very unique. And I think, Mike, we talked about obviously running instructor-led training programs. So via online, this kind of means we can provide a higher level of education and teaching through that means as well. So I think that covers that fairly well. So what I want to run through here is really just a couple of animations for, we're not going to spend a lot of great deal, but this is where we talked about the plug and play scenarios. We're very fortunate that we've developed animated safety briefing videos for all of the aircraft types that's currently flying offshore internationally. So we got a whole very detailed database for all the aircraft, and the detail is phenomenal. So we have used all of these animations throughout our DBOSS and HDSTP training program that shows the highest quality. Now, these kind of animations are actually coming from operators itself. So we will customize the labels exactly to the customer's requirements. So that aircraft, every 139 that we do, or S92 or H175, we develop that specifically for that customer. So when the passenger look at the safety briefing video, and as Mike said before, that memory implant, when they look at the label or look at the specific procedure, they will see that in the real aircraft. So the connect there is again, that kind of motor skills, and this is your category, your PhD level, Mike. You can take over here. I'll get stuck somewhere about that.
Okay, thanks, Mornay. And there's a question about the emergency exits, specifically with the S92, but I'll expand it into the other aircraft. So we've got AW139 presented here, but for the S92, to the best of my knowledge, the only study that's been done anywhere in the world to look at the forces required to open an emergency exit have been done on the S92. And I was fortunate enough to be able to run that program, and we tested over 150 people. I also tested the actual aircraft with a device that was specifically built to test that, and the forces that were required to break that seal. Contacted the OEM, tried to get information based on the testing that they do. We also had a FEA model developed, a 3D model developed to do the testing. And we looked at the training application. Realistically, the forces that are required to open the S92 exit, the push-out exit in particular, is greater than that, than what's used in the training environment. The training environment, if individuals are running a METS platform, is roughly about 14 pounds force to open those windows. And for those of you who have used that in the past, you know that if it rolls too fast or the water ingresses too quickly at a certain angle, it can open those windows. In the actual aircraft, the forces that we noticed were roughly around 120 pounds or 50 kilo to open those windows. That sounds quite high, and in fact it is. It was a surprising number that we saw. So when we tested the both dry and wet, we ended up doing nearly 1,500 egress sessions, both dry and wet, with the individuals. We were able to identify the most optimal egress sequence, and it's not a strike in the window, any one of the four corners, particularly if the seat strokes. So if the impact forces are great enough, as they were in the Kruger event in 2009, and the seats stroke, then the individual is moved roughly 18 inches from their 16 to 18 inches from their original position. And that changes the dynamic of egress. So we've taken that information and put it into the HDSTP and the DBOSS and talked about that specifically. For the S92, it's an elbow in the closest corner to you, and it's a full strike across the body. That generated enough force, and I've published 5 different articles on that. And any of you that are interested can please just contact me. I'll be able to pass that along to you. We looked at all those forces, how it's generated, how long the period of time needs to be to crack the seal and then be able to open that window. And it can be done. We actually found that over 80% of the individuals who were tested, if they use that specific technique of using their elbow across their body in the lower corner of the window closest to them, they were able to generate enough force to open that window. And we replicated the forces in the simulator by adjusting the spring holding devices that are in the edge of the window frame, and we were able to replicate that. So unfortunately, that research doesn't necessarily get passed out to the other training organizations, and it sits on a shelf as a technical document. We publish the peer-reviewed journal articles to get out there, but quite often those don't get to the training environments either. And I would imagine that many of you don't necessarily know the forces for the different types of aircraft. The AW139, for example, that hasn't been tested. Any of the other aircraft that I know of that are being used in the offshore haven't been tested empirically. So that's work to be done. And that's a fundamental question when we're talking about underwater egress. How much force does it take to open the window? What factors influence that? And it's important for us to be able to identify those as we move forward. But on the front end, we at least have a baseline amount of information that we can use for a good brace position. And I know there was another question about whether we could replicate in the simulation or in the animation the difference between 1 meter and a 5 meter wave. At this point, we're not necessarily in that space, but what I can tell you is, despite the request or requirement from the EASA new standards, I think it's CS 29 and 27, talking about flotation devices and the stability of the aircraft. If you look at the accident investigations, and Steve and I went through over 300 events over the last 30 plus years and looked at all of the events, we were able to distill those down to a fairly small number where we had the information related to whether it was mechanical failure, whether they had to auto-rotate or it was single engine, whether it was a controlled flight into terrain, and we're able to look at those components. But even with flotation devices, the majority of helicopters invert almost immediately or shortly after touching down on the surface of the water. The dynamics of the rotor, the wave action, all of those components put together, it's difficult to keep the helicopter upright. So we know from the events that the majority of individuals that were involved, if it was survivable, then they had to egress underwater. Rarely do we see the aircraft stay upright long enough to be able to egress into a life raft. It does happen, there's no question, but these are important things that we're putting into the program and moving forward. So hopefully that that answers that question.
Yeah, I think I'll leave just one thought as well. Doing the passenger safety briefing videos, the S92 cabin windows, the 10 cabin windows, that's actually the only cabin windows used offshore that doesn't have a pull tab. So most other helicopters, you have a pull tab that you remove the seal around the window. Most types that we've developed, they have those seals, pull tabs around them. So that reduced the amount of force that's required to jettison a window, where the 92 window is just a rubber seal that's attached to the airframe. That small detail, and I think with the ongoing OEM debate on making larger exits and making those more accessible, that might have to be one thing that becomes a pull tab as well, and not having the window, this amount of force that Mike is talking about. So
I have another question as we're moving along here, Mornay. Just talking about the simulation and the importance of being able to witness the actual physical interface that's different between the aircraft. And I agree with that statement, except that we do have research that shows that if someone can see a good representation of what's going on, they actually can start to build a good reference point in their motor skill planning. So the premotor cortex is activated in the same way when in their thought about a particular task as it is when they actually do the task. So the same priming that occurs in the premotor cortex occurs both when you're just thinking about it and when you actually physically do that. So the more realistic the 3D animation is, the better that connection is. And when they sit in the actual aircraft and they run through that and they see that actual physical component that's there, that locks that in. So we actually see that there's a consolidation of the information that was used in a 3D animation into the actual space. And that is actually quite robust when we consider the testing beyond just the practical application. There is no question you can't replace everything with a digital component. Having people go upside down underwater and practice opening a window and getting out, absolutely a key component of the entire equation for them to be able to focus that. Climbing a scramble net, putting a canopy up on a life raft, getting into a lifeboat, physically doing all of those components, extremely important. There's no question. And we're not trying to replace that. This is to be able to help close that gap as we move forward.
Yeah, and I think the value that we've added as well, I've worked very closely with the OEMs, that the animations that we develop has been validated by the OEMs. And I know we're doing some work for one of the OEMs at the moment to actually develop an animation for their own safety group to circulate through all the operators. So that's a significant thing that doesn't exist anywhere. If you look at the existing BOSS training program, nothing of that is to the degree that we've went into to make sure that the animations line up with one part of the standard that we want to emphasize the procedures to follow.